Welcome to Physics with Mr. Brazil. Today we're looking at deriving the range equation, which is up here to the left, where we look at the x direction for projectile motion, and delta x is equal to v initial or v naught squared, sine 2 theta over g. And most textbooks and online, you're going to have to look at gravity as a positive. We'll look at this in the derivation why it's so, but it's just something to remember. But to go on, let's say you got a ball that you're kicking or cannon, whatever. We put our coordinate plane, we have an object in a parabolic flight, and in this case y initial will start at 0 and y final will equal 0. So in other words, these have to be equal. And from this, we can determine the change in the x or horizontal direction, okay, delta x. A couple things also to review real quick is that the initial velocity is that tangent vector, v naught initial. The x component of the velocity is vx naught, and it does not change, it's constant. Okay, that's important. It's a constant velocity in the horizontal direction. So at Vy final and in the x direction, the velocity is still the same as its beginning. Now, Vy initial is changing. That will change eventually. It speeds up, or initially starts at a high speed, but when at the apex, Vy will be 0 at that point and then start speeding up again on the way down. Okay, that's good review. Next, also, these are component vectors that make up Vy naught. So if you've forgotten or don't know, Vx naught is equal to V naught, the initial velocity, times cosine theta, while Vy naught will be V initial, okay, V naught, sine theta. Okay, so far good? All right, let's take a look at how this is all going to come together. Well, in the y direction, let's take the all-in-one, or what I call the Swiss Army knife equation, because it takes all kinematics pretty much. So Vy initial equals, Vy final equals Vy initial plus Vy naught t plus 1/2 gt squared. All right, so far good. We know that the y's are going to be equal to 0. So 0 equals Vy naught sine theta plus, I forgot the t, so let's put that in, t plus 1/2 gt squared. All right, well, we don't see a delta. Oh, well, let's put in the delta x. Let's do the same all in one. X final equals x initial plus v x naught t plus 1/2 ax t squared. Wait a minute. We just said that velocity in the x direction is constant. Therefore, there is no acceleration. And delta x must equal Vy naught cosine theta t. Okay, hey, they have something in common. That's right. All three vectors, if you take a look over here to the right, all three vectors will share the same time throughout the flight. Okay, so let's solve for t. T will equal delta x over V naught cosine theta. Well, we can plug that in for the y component, or the y direction, so let's do that. All right? So 0 equals V naught, parentheses, sine theta. T is now delta x, V naught cosine theta. That looks good. So 1/2, we got a sine over cosine. That's like tangent. And the V naughts look like they're going to cancel. So we'll tackle that in a moment. Let me put that in parentheses. Okay, in G, no, we're not going to do T, but we're going to go parenthesis delta X over V naught cosine theta squared. All right, let's go back to this on the left. Well, the knots are going to cancel. I'm going to, just for purposes of doing math, I'm going to keep delta X first. Delta X sine theta over cosine theta. And you'll see what's going to happen. So 1/2. Oh no, let's not do 1/2. Let's get rid of that. 1, and let's just do this. G delta X squared, because the 2 distributes to everything in the parentheses. So we're going to have delta X squared. We're going to have the 2 down below from the half. We'll have V naught squared. And I'm going to put parentheses around the cosine because students sometimes get confused with the 2 placed inside for the square. All right. Doesn't look yet like above, but if you look at this carefully, we'll pull out the delta X. I'm going to keep this as sine theta. And I know we could write tangent, but you'll see it in a little bit why I'm going to keep it apart. Plus G delta X squared, that doesn't change. Okay, oh no, that is going to change. Let's get rid of that. We're going to pull out a delta X, so that's going to be a singular. 2V naught squared. The cosine squared remains. Okay, and I'm going to pull out delta X. I can factor it out. Well, if I divide both sides by delta X, this disappears because delta X into 0 goes away. So 0 now equals sine theta over cosine theta plus G del X, not squared anymore because we factored it out, 2V naught squared cosine theta squared. Hey, we're almost there. Let's check this out. I'm going to move this over here to the right. And I'm going to go negative G delta X. I can move either one, but I'm going to go with this. 2V naught squared cosine theta squared equals, let me back that up a little bit, equals positive sine theta over cosine theta. Well, check this out. We got a cosine on the bottom. If we multiply both sides by cosine, this cosine disappears and one of the cosines remains, so let's put a 1 there. So this is gone, all right? So I'm going to put this, rewrite it so that you can visualize it. So negative gx over 2 v naught squared cosine theta equals sine theta. This is getting interesting, so let's do it. Delta x equals, all right, we're going to have v naught squared 2 sine theta times cosine theta over negative g. Oh, I can now see, can you see that? The negative g, the negatives get cancel out. In other words, we're going to get that positive. So that's where that came from. But what the heck is going on here? 2 sine cosine theta. Well, we're going to have to go back to our trig class. And I'm going to write it right here on the right. 2 sine theta times cosine theta has a trig identity of sine 2 theta. Check it out. You can look it up online or in a textbook. So now we have derived the range equation. It'll be v naught squared, okay, sine 2 theta over, and I'm going to keep the negative g, but if you can visualize or understand, that's why textbooks and folks online will put this as a positive G on the bottom. So it looks tedious, but really the skill that you're developing is substitution, knowing to substitute the x component into the y component, or the other way around, but it's easier to do the x. Because you may have problems that you'll have theta and you'll have x, and you need to find initial velocity. Or you may have a problem that needs to be in terms of v naught. By doing these substitution or practicing this substitution skill, you develop your physics and math skills at the same time. So keep practicing physics, do a couple problems every day, and you'll get better and better. Bye.